secretary for like other of these.
You gotta tell me that.
I didn't even take PE. You didn't know? Yeah. She said, "Hey, you gotta get on the Zoom and you gotta do exercise." Just kidding, you have to do it. Okay.
Yes. What, baby?
Brooks just said that Jesus is gonna beat the F word out of me.
Y'all gosh, listen, it's too early in the morning for this mess. Do not. Don't you start me. It's when I can tell by the look on your face, you stop tell me something crazy.
Yeah, I'm down. Have some.
Taking on this silence. Like my daddy told me yesterday. My daddy said he found a shirt.
Why?
It says my patience has been tested and I'm negative. You are. Look, he said, please drop him this morning.
I am not. I am tired. Isn't it probably loud? Hey guys, the windows down.
Because I am negative. Morning.
We can't smell like this.
Transition.
Okay, so I lost my stuff again. Why do you keep
Flip
moving?
out.
I don't know.
That's good.
You know me, baby.
All right, man. Let's do some math.
You know nothing.
All right. So I'm gonna go over this with you. So this is kind of a review for over the last. I mean, we've been working on this stuff for a couple of weeks now. So this is some review for us, and we'll need most, if not all, of these skills today to be able to do this kind of culminating thing that we're doing today. Tomorrow will be your test review. Wednesday will be your test. Just FYI. So remember, when we are asked to sketch the graph of a line, we need to use the slope-intercept form. And luckily, it went ahead and gave us that down here. So the intercept is going to be -3, and the slope is going to be -2/1. It's really -2, but because I know I'm about to need the rise over the run, I'm going to go ahead and write it like that. And then I can interpret this slope to mean down 2 and right 1. Remember, because this is the rise or the up and down change, and this is the run or the left and right change. And so the first thing you'll do is you'll sketch a plot of that intercept at -3. And then we're going to get one more point so we can draw our line. So I'll just go down 1, 2, and then to the right 1. And that's going to give me what I need. So let me draw my line here. There we go. Let's make it really big there. All right. So that is sketching a line with 2 points. You need an intercept and you need a slope so that you can count to find the second one. So you need at least 2 points to sketch a line. All right. For the next one, this is from the circle stuff that we did on Thursday and then practice a little on Friday. So remember that the center is at H, K, and the radius is R. And the general equation or formula for a circle looks like this. It's x minus h squared plus y minus k squared equals r squared. Right, so the first thing I need, and anytime I'm working with circles, is I need these two things. I need a center and I need a radius. So center, radius. So this is similar to when we are working with lines, we need a slope and an intercept. Now we need a center and a radius. And so the center will be at 2, -1. And I got those numbers from here. And the radius is going to be the square root of 4, which is equal to 2. Yes, sir.
You know how H is 2?
I do know how h is 2. Yes.
You do?
Mhm.
So why don't we square it?
Why don't we square what?
The H, because it says square root.
But this is what we're trying to find. H and K, not H squared and K squared. Yes, ma'am.
Why would we square 4 if it doesn't have the square next to it?
Because the general format of the equation looks like this. And so remember, we are constantly trying to make things look like the formula so that we can pull these things out. So let me write it up here. This is x minus 2 squared plus y minus negative 1 squared equals 2 squared, which is 4. But r is that number squared. And so here you're seeing 2 squared in the final version because it's been cleaned up. So that's why you take the square root, because you're really looking for a number squared that will give you 4, because the radius is squared. So that 4 is r squared. We want r. So we take the square root, which is how we would find the number that is squared to give us that number. That's a good question. All right, so you can see here why the signs appear to flip, right? That's not exactly what's happening, but it seems like that's what's happening. Because I am looking for the center H and K, and in this formula, there has to be a minus, and then I just grab the H. And so the H is actually a positive 2, because I pull it out. Here, it appears that this is a plus 1, and it is. But because the formula is minus, when I'm looking for K, I have to have a minus before I can pull the K out. So how do I make y plus 1 y minus something? Well, that would be y minus negative 1, because the minus negative will turn positive when you count that in. That's why those signs flip out like that.
But, so if we're gonna make it a positive now, we have to change the whole formula.
We're not gonna go in that order though, and there's a method to that.
But in practice, really all you're doing, you need to understand this is why it happens, because you'll forget otherwise. But in practice, you're just flipping the signs when you take out H and K. So if you see a minus 2, it's going to be positive. If you see a plus 2, it's going to be negative. And then when you get this number, you need to understand that the R is hiding inside of this number. Because this has to be squared to pull out R. And so how can we write 4 as a number squared? Well, it will be 2 squared. So this is the hidden R. If this was a 9, what would R be? 3. If this was 100, what would be R be? 10. Yes, ma'am.
Do you always need it?
So we're gonna use these all interchangeably in square, split function,
Right.
process.
Let me graph it for you. You'll need to do this today. And remember, the graphs don't have to be, these are sketches. So these are just kind of give us a general idea. You want to make it look as nice as you can. However, it's not going to look perfect because you don't have like a compass. So the center, we plot the center first. So this is 2, negative 1. And then I have a radius of 2. So here is a point that is 2 away. Here is a point that is 2 away up here. And then we can find another one down here. And then there's another one here. Why can't I put one here right now? Why wouldn't I just go ahead and put one here?
Because you can't do diagonal.
You can't count 2 diagonally on a coordinate grid. That's why. So that's why we go up, down, and side to side, because that is how I can count 2. I don't know what 2 looks like on a diagonal. A perfect diagonal would be the square root of 2, but ain't nobody got time for that, right? So we're just going to, just kind of in general sketch what the circle would look like. Because it's kind of gross looking, whatever. As long as you have a general idea where the boundaries of the circle are, it is good enough for what we are doing here today. Okay, so that's in general what your circle should look like. You got a radius of 2. instead of 2, -1.
So when we factor
Okay.
out
Write the slope-intercept form of the equation of the line described. So this is the given line. This line is given to me. We have a given line, and then we have a new line that we are trying to write. So I have a new line. So I'm just going to make sure that I don't get lost and I understand what the old one is and what's the new one. So the new line should be perpendicular. So I like to just make a note of that so when I'm working on things. Then I need you to think, in order to write the equation of a line, I need 2 things. What are they? A slope and an intercept. So I'm going to need a slope and an intercept. The only piece of information I take from the given line is I use it to get the new slope, and then I care nothing about it ever again. So if the old slope is 7/9, my perpendicular slope would be -9/7, because that is an opposite reciprocal for the perpendicular slope. We flip it and we change the sign. And then I have to find my b, right? Because now that I've got my slope for my new line, I don't care about the old line's intercept or anything else. But luckily, I do have a point x and y. So if I start, I know that this will need to be a line in the form y equals mx plus b. I have the m, right? -9/7x plus b. But I also have this x and y right here. And I'm going to plug those in. So this will be 4 equals -9/7 times -4 plus b. And so at this point, I'm trying to find b. So I'm going to solve for b, right? That's what I'm trying to find. So I'm just going to calculate that. It'll be a fraction. It doesn't mean it's wrong. Sometimes it's nice. Sometimes it isn't. This would be what, 36/7? Okay, 36/7. We are not scared of this number because we know it just acts like any other number. I'm just going to subtract it from both sides using my calculator. That goes away. And so 4 minus 36/7, what is that going to give me? Does anybody have it off the top of their head? -8/7. So look, that goes up here. And look, now that I have m and b, I'm ready to write the equation of my new line. Y equals -9/7 times x minus 8/7. And there it is. This is the equation of a line that is perpendicular to the one they gave to me. This one is especially going to be important for us today. Okay. Finding that new line. All right. Find the slope. Now remember, to find the slope, we are just going to count the rise over the run. Right? So starting at this point, I would go down 1, 2, 3, 4, 5. And then I would go to the right, 1, 2, 3, 4. So the slope of this line is -5/4. Right, this is 5, this is 4. We went down there, so, or you can just notice at the end that it has a downward slope. Is it 5? There's just miscount. Thank you.
Could you start at the bottom and do like go up 5
Sure.
and go left?
Yeah, hold on, I'll show you that in blue. So this will be 5. Thank you for the good catch.
But if you start from the bottom, how do you know it's not all in?
Because this is going to be, so if we go up this way, up 5, left 5,
Yeah.
right? So it's still going to be -1. It doesn't matter.
Mhm.
And we still are going to know that no matter where the negative ends up, the line is going down from left to right. So that final slope is going to have a negative.
Yeah, I remember that.
So this would be 5, -5. So but you see we end up in the same exact place. It doesn't matter. You could choose other points on this line. Look, here's another couple that look nice, right? This one would be 2 and 2. 2 divided by 2 is still -1. It doesn't matter which ones you use or how you get there. long as you get there. Right? Finding the slope given the points, this is just a quick review. This would be y2 minus y1 divided by x2 minus x1. So we'll label those and just use the formula. x1, y1, x2, y2. This would be 20 minus 16 over 1 plus 9. That'd be 4 over 10. Is that fully reduced? Nah. So that would actually be 2 over 5. Reducing that all the way down. Got a couple of different ways to find the distance between 2 points. Just as a reminder, I'll show you both ways. You know, I like the Pythagorean theorem, so I'm going to use that this way. That'd be 1, 2, 3, 4. This triangle has a length here of 5 and a length here of 2. So using the Pythagorean theorem, that would be 2 squared plus 5 squared equals c squared. 4 plus 25 equals square root of 29. You could use the distance formula and do the exact same thing, and you would get the exact same thing. And on this one, I'll guess me.
So for there, would you put, I wasn't sure if it was, if it was like the square root or exact.
It doesn't specify, so either is fine. Sure. What would the, did you put the decimal? What is it? What did you get?
You could, 5.39.
5.39? Yeah, that works. So you could do either of these. This is the exact, and this is the approximate. Notice it doesn't say in the direction which one I want, so I will accept either of those, and they are both correct. Okay. Under what circumstances do you think that it would be preferable for me to use the decimal? Why would I want the decimal? Can you plot the square root of 29 on this grid? Can you plot 5.4? All right, that's why, in case I want to plot it or I need to get an idea of what that number is. Because maybe looking at the square root of 29, I'm like, I don't know what that is. That was close to 25, so I can kind of like imagine that I would much rather see a 5.4 if I'm trying to count. All right, so using the distance formula is another option. I do not care at all which one you use. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Maybe you can see why I like the Pythagorean theorem a little better. It's just a little less nasty looking. But it's going to work every time. x1, y1, x2, y2. And then we'll just start plugging stuff in. So this would be 2 minus 8 squared, and then we'll have 0 plus 4 squared. See how on I am this morning. It'll be 36 plus 16. At 50? Did y'all get square root of 50 on this one? Or maybe it's 5 root 2? No? What is it? I'm not on this morning. It's sad. What'd you get? You're good.
I got 2 square root 13.
I did.
Why'd you do 0 plus 4?
Because 0 minus negative 4 is going to give me. Either way, it's fine. Well, let's see. Let's see how I messed it up.
Yeah, 2 plus square root 13.
2 root 13. So 36. Oh, it's because it's 36 plus 16. I just can't add. We know this. 2 square roots of 13. What's the decimal approximation to the nearest?
7.2.
Or 7.2, whatever. One would be more exact, and this one might be more useful to us. Exact. And approximate. Whatever. Good. Are there more, or is that it? That's it? That's all I do? Okay. I feel like that's enough. All right, so I'm going to give you a second just to kind of, you might want to leave the do now out because it's got an example of every calculation pretty much that you'll need today. We're going to put a lot of these things together today. We're going to put slope, lines and circles all together. So if you want to leave that out so you can refer to it, I'm going to give you the notes. So we're going to do those, and then we're going to practice. We're not going to be on the computer at all today. All your practice will be on paper today. The notes are big because, you know, we got lots to do.
Alright, 5x cubed minus 10x squared. So a
So
lot
this is
of
the
times
last
when
new thing on this week, and then this is a review tomorrow test on Wednesday.
I know that I'm gonna have three. Because the highest in this quadrant.
All right, I know it's boring, but y'all need to get up. You all miss it. You all miss it, and I don't want you to miss this. All right. All right, so we are talking about tangent lines today. And a tangent line is just a line that touches the circle. It touches the circle at one single point, right? It just barely skims along the outside. So the tangent line of a circle is perpendicular . Perpendicular
I'm gonna do the x minus 2 first, because there's something funky that happens with this guy.
to the segment created by connecting the center
What's my first solution?
and what we call the point of tangency. Tangency.
So 5x squared.
Point of tangency is the point where that segment in our line is going to touch the circle. So just to give you an idea of what that actually will look like, and I encourage you to draw this. This is the center, right? This is the center of the circle. Here is the point of tangency. And this thing is the tangent line. And then we have this segment. Oh my God. Okay, I'm just going to cheat. We have this segment from the point of tangency to the center. And this actually makes a perpendicular line right here. And that makes a right angle. So those two things are perpendicular to one another at the point of tangency. So you can see now how we're about to put all this together, right? We've got a circle, and then we've got two lines that are perpendicular to each other in such a way that they both cross through this particular point that lies exactly on the circle. But the line cannot cut through the circle at all. It's got to just bounce right off the edge of it. So there's a lot of things going on. Okay, so here's we already know this word. These are your new words today. Tangent line and the point of tangency. Right. Review of perpendicular lines for the second time today, because it's really important in what we're doing. Lines that are perpendicular have slopes that are opposite signs and reciprocal. What's reciprocal mean? Crickets. What's it mean?
The reason why it's up 2 is because that is the root that
Is it like it?
if we're taking
Opposite sign is swapping the sign. What else do we do? When we have perpendicular slopes, we switch sign, and what else do we do? You flip it. This is the flip. We want to move towards using that word. This is not a mathy word, right? Because flip could mean like, that. That's not very specific to what we're doing. So line A and line B are perpendicular to each other. Given the slope of line A, write the slope of line B. So if this is line A, the perpendicular slope would be -1/3. So this slope can be expressed as a fraction of 3/1. And so when we flip it, we need that 1 on bottom because we don't have a fraction to flip until we have that 1 in the denominator.
Oh, yeah.
Okay?
I thought, okay, I see.
Okay. So line A has a slope of 3/2. So the perpendicular slope would be -2/3. And finally, line A in number 3, it's -1/5 for the slope. So the new slope would be +5, right? Because we would +5/1, and so the slope would actually be 5. We do not write final answers in cleaned up equations with that 1 in the denominator, okay? That's not good grammar. That's like not capitalizing your name on your paper. It's just not what we do. It's right, but it's not proper. So you have 6 steps to complete one of these problems today. So when you are working, where do you think I'm going to point you back to first? These 6 steps, okay? So if you're lost, if you do them in order every time, you can do every single skill in this list. We have been practicing this. We just did all of these things separately in the warm-up. And so if you can just count to 6, 1, 2, 3, 4, 5, 6, you can complete one of these problems, okay? But they are complicated. That's okay, because you have all those steps. Find a line that is tangent to the circle at the point given. So step number 1 says to draw the circle and plot the point. Okay, cool. We just did that. What do we need to draw the circle? We need the center and the what? The radius. The center of this circle is 0, 0. Notice there's nothing in there with the x and the y. And the radius of this circle is the square root of 5. So let's go plot the center. And remember, when we're doing this, we want to count the length of the radius up, down, and side to side. Do you know where the square root of 5 is on the coordinate grid? No. So we need a what? Yeah, approximation, a decimal. So that's approximately what? 2.2. Okay, now we're cooking with grease, right? Like we can actually do something. So I know where 2.2 is. That's 2 and a little more. 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 Right? I'm going to cheat. I'm going to try to. I'm probably not even going to be successful at it. It's just kind of pathetic, but whatever. All right. Let me try to make a nice circle just so it's easy. Oh my God. No, that is not what I wanted at all. Maybe by the time y'all get yours sketched, I'll have my life together with using this. But we all know that's probably doubtful. So we're going to try that. Okay. Okay, it's not horrible. Yeah, it is. It's okay. There's probably a lot of people that ain't even done drawing there yet. But let's try it like this. Why don't I just make mine junky like y'all's? There we go. See, it's kind of junky. That's okay. All right, have we completed step number 1 yet?
Yes.
Draw the circle and plot the point. Absolutely. Draw a line connecting the center and the given point. The given point is 2, 1. I'm going to plot that on there. That's 2 and 1. There it is. And it says to draw a line connecting these two things. There it is. Oh, my stupid circle. But let's do this. Let me turn off the shape. And do it again. That's okay. Now y'all won't feel bad about your junky circles because mine looks like garbage too. All right. So step number 2 is done. We connected the center and the point on the circle. Now number 3 says find the slope from the center to the point. And so we're looking for the slope of this line. So the slope of that line would be rise of 1, run of 2. So the slope is 1/2 of this line in yellow. Rise of 1, run of 2. Okay, step number 4. Find the slope of the tangent line by taking the opposite reciprocal. And that just means flip and change signs. So this, let me write a note here that lets me know that this is about to be the slope of the tangent line, which is just the perpendicular slope, right? So M is going to actually be -2 in this case. So this is the slope of the tangent line because it's just the perpendicular slope. I haven't done anything super crazy yet. Everybody with me so far? Why I did that? How I knew to do that?
No.
Okay, what is your question?
No clue what you
We're on step number, what step are we on?
He wasn't here last week.
He missed circles and that was all. So find the slope of the tangent line by taking the opposite reciprocal. So this is just when we are flipping and changing the sign of the slope.
do. Well, how did, but so, like in every one of these things that you're doing, you always, like, take a 1 after x2 and y2 and then you put it in the square root?
Oh, circles.
Yeah.
So, yes, I will get with you about the circles. Are you good with the rest of it though? Can you find the slope and all the stuff that we're flipping and all that?
Somewhat.
Okay.
I guess.
All right. It's been about 5 or 6 days since you've been with us, so we'll get you there. All right, so what's the next step? Then we're already on number 5. Use the point and the tangent slope to find the y-intercept. Well, that's just this thing that I do. I want a new line. I need an M and a B to get a new line. My new M is the -2 that I found. And now I'm going to find my new B. Where do I get the y and the x this time, you think? The point. There it is up here. Look. X, y. So this is going to be same process. Nothing is new here. We're doing exactly what we've been doing with these lines. I plug in the x and y and I solve for b. So this would be 1 equals -4 plus b. And then I'm going to add 4 to both sides. That goes away. So b is equal to 5. Can I write the equation of the new line now? We call this the tangent line. Okay, so that's going to be y equals -2x plus 5. So I found the equation of the tangent line to this circle. And now I can plot the line because I know how to do that, right? What's the first thing I do when I'm graphing a line in y-intercept form? Or slope-intercept form, yeah. Do the intercept. 2, 3, 4, 5, there's the intercept. What's the slope of this line? -2 over 1. So if this is a slope of -2 over 1, this means down 2 and right 1. Down 2, right 1. And now I can draw a line. See how it crosses directly through that tangent line that we just plotted? Like the tangent point here. Here it is. How do you check your work on this one? Well, if it doesn't graze the circle and go through that point we plotted, then it's wrong. We're going to do some more of these. This is a long process. All right, let's go again. Example number 2. So first we're going to plot the circle, right? And we need a center and a radius. Center is 0, 0. Radius is the square root of 17. So I'm going to need to make that into a decimal in order to kind of get a handle on what's going on. I think it's going to be a little over 4. Should be a little bit over 4, maybe 4.1. Yep.
So where did you put that in?
Okay,
Why would you put that
If
in?
we're to plot this one,
just do square root of 17 and hit the double arrow button to change it over to a decimal. Got it? So now we're ready to plot the circle. It's centered at 0, 0. And I'm gonna go up 4 just a little more. 4 and just a little more. 4 and just a little more.
Alright,
It was hard to see all that over here.
so I lied, I'm sorry, there's 7, not 8.
Okay, here we go. I can do this.
Alright.
I can do it pretty good on my own paper, but up here it's pretty nasty. Okay.
So technically,
And then I have plotted my circle. Now I'm gonna deal with this point. This is gonna be -1, 4. That's right there. You're gonna draw a line from the radius to that point. Now I need the slope. So what's the slope of this line? It's clearly negative. Got a rise of 4 and a run of 1, so that's gonna be -4.
Alright,
So now let's find the tangent slope.
12 is 1 times 12, 2 times 6. No, always look at the smallest term.
It's just perpendicular, so the new m is gonna be 1/4,
You
probably.
got 1 and 3 basically. 3 is the numerical GCF. Make sure you take
So
out the
now,
entire
let's find the equation of our new line,
because both of
which is the
these
tangent
have
line. So we need a slope, which we know is 1/4, and we need an intercept, so the only thing left to do now, yes ma'am?
Alright, if you don't take out the entire GCF, it'll be off the
What?
graph.
For n equals
So if it says backward, I would stop. But it's backward.
I just calculated the slope of this line.
So I'm gonna do the x minus 4 first. That one's gonna give me x equals 4, right? Alright, so
The rise over the run.
clear, okay? We're
So
gonna
the
take
rise is
0,
4,
which goes
and the
back to that
run is
other
4.
example.
and
5x
is
equals 3.
Okay.
then it's 4 and then on this
Zero.
one.
So be very careful. To undo something being huge, we do not take
All
the
right.
square.
So now we just do that thing, where I've got an x and a y here. And so I'm just gonna do y equals x plus b. Let me plug in all my stuff. This is gonna be 4. This is gonna be 1/4. X is -1, and then I'm looking for b. So this will be 4 equals -1/4 plus b.
There are 3.
And just like before, we're just fine. It's fine to have a fraction here. We're just going to solve. So if it's -1/4, I would need to add 1/4 to get that to go away. So 4 plus 1/4 is 4.25 as a decimal. Why do you think I went ahead and made that a decimal? What am I about to have to do with that b? Plot it on the graph, right? So like, I'm gonna need it to be a decimal soon anyway, so. You know, if you don't like that, that's cool. All right, so look, I have my new line now. I'm ready. Y equals 1/4 x plus 4.25. That is the equation of the line. I'll take it like that. I don't need it in fraction form. So let's go ahead and plot this one. Let's go ahead and graph this line. So I'm gonna go 4.25, which is right there, about, right? And then I've got a slope of 1/4, and that tells me to go up 1, right 4. So that's gonna be about right here, and then 1, 2, 3, 4. It's gonna be about here. Now I'm gonna draw my line, and as long as it skims over that circle and touches that point, then I'm good. There it is. What wouldn't work is if your thing went like your line that you drew went through the circle or something like that. Or maybe like if you drew it and it didn't touch the circle at all, you would know that that was incorrect. Like you would know for certain that you've messed up somewhere because it's gotta just graze the outside of that circle. All right, let's see how far we can get on example number 3. What should you be looking at when you're like, I don't know what to do first? What might help you here? The steps. I'm going to write them up on the board so you don't have to like flip flop between your notes and stuff. Flip flop the sides. Have to read it again, okay? Let's see how far we can get on this one right here. Okay. So first step. Alas, no confidence. Right. Oh, this one's good.
Alright, so what you have to do is you have to, so you would write number 1, a squared plus 3a, you would write it down, and just write the original question. You would factor it, and then you would solve it, okay, once the factor is solved, not the factor. Then it says to double check to make sure you have all of your solutions, right? So for number 1, you should 2, the height is 2. Some of these are not that bad, but for number 1, the easiest is A. Looking at A. So I said 160, walk around with it, but you have sturdy things. Some of them are that here. The things that I originally had planned for your classwork, I'm going to make it.
All right. First thing we're going to do is we're going to find the center of the circle. There's numbers in there now.
It just
So
helps
that's
you.
31 of the center of the circle. We can take the square root of that and prove the radius. And we'll off the center on the edge. It's just a number. And we're going to count up, down, left, and right. That's about 2.2.
If I don't know how to do it.
So you'll pop the center of the circle. And then you'll count up, down, left, and right that far. And then you can draw your little goofy looking circle like that. And at that point, you will be on still on step 1.
No. This morning was a me problem, not all problem. I don't do other things. Don't go for it.
Just got your center. Okay, now plot the point grade.
Oh yeah, I'm there. Like I was apparently.
So what's your center?
I have to have my name on
So
it.
you positive 3, negative 1. Okay. Let me just swap this out. Okay, now you're on step number three. Just find the slope. You gotta count. Yeah. We'll do this and then find the slope. But you gotta find the slope of this line. And so that'd be number two. And so what would the perpendicular slope have? Yeah. Negative two.
So M is -2?
This is positive. One over two.
Right, so that's how you find your M.
Yes. And then you need a new end. And an old and a new. Okay. Should be negative down here. The slope should be negative. Not to go over this one. I want you checking along and seeing where it fell apart for you. If it did, and if not, making sure your final answer looks like mine. So R is 2. Yeah. It doesn't matter which way you go, it's gonna be the same. You're welcome. First thing we want to do, find that center of the radius. All right. I'm gonna just silently start working through this one. You want to glance up and see where you're at. In a long process like this, there is really no way to start learning how to do it until you start and then get stuck, and then we get you unstuck, and then you try again and you get a little further and get stuck again. It's normal. And then I'll get you unstuck, and then we'll try again, and you'll get further and further and further until you're finally able to complete one on your own, and that process will vary in how many times it takes you. That's fine. You just gotta do enough to where you get unstuck a little more each time. So step number 1, draw the circle and plot the given point. Do this. All right, I said I would do this quietly so people are still working.
You all have an assigned number, so I'll just give 5 out. I'll randomly spin a number. 5 seconds or 5 seconds. Wonderful. 908. We got 31 minutes. Yeah, I agree with your brother. Yeah, let's just round to 10. Let's just have it.
Let's see if it works. Let's see if we messed it up something. So this would be at 0. This would be 1, 2. Sorry.
Like, she wrote horizontally, like, this is all one line. And then she wrote again, and then most of the right way.
So on this one, I'm gonna walk you through. And then we're gonna try number 4. We're gonna get a little bit further. Take notice to where either if you got all the way through and you got what I got, and that's awesome. But if there was a point where it kind of like, if you're following along step by step, and it kind of like derailed at a certain point, let's try to determine whether it's because A, you didn't know what you're doing, B, you made a simple little mistake like a sign error or something. Whatever, we just need to figure out what the problem was so we can fix it. So step number 1, I drew the circle and I plotted the point. To draw the circle, I had to have these 2 pieces of information. So I plotted the center here, and I moved the length of the radius out from the circle so I could get a rough sketch. I plotted the point that they gave me. I drew a line from the center to that point and found its slope. Then I started working on the tangent line equation, for which I need an m and a d to write. Okay, so my slope, I need the perpendicular slope for the tangent line. So I flipped it and changed the sign. 1/2 became -2/1. And so then I came over to solve for my b, which I don't know what that is. So I have to use this process. So I plugged in the slope and the x and y from the point. So here's the y and here's the x.
How come you use the -2 for your y?
Because
And
it
your-
just so happens to be -2 also.
Oh,
So from there, I solved for b and determined that it was 0, and I was suspicious because I was like, that's weird. So I went ahead and checked it anyway because I didn't feel like I had done anything wrong. So I went ahead and plotted the line just being y equals -2x. That's an intercept of 0, down 2, right 1. And once I got my line sketched, I could clearly see that all of the criteria fit together. It skimmed across the edge of the circle through the point that it's supposed to. So even though it's weird that that's a 0, it's correct. So I know I'm good.
Look at these little slope parts.
Which part? The slope part. This?
Yes, but
Okay, so this is the center that I got from up here. This point is the one they gave me. So I drew a line between the 2 and found the slope of this line. So that would be, to get from here to here, I would go up 1/2. This is my up 1, my over 2. And then I need a perpendicular slope for my tangent line, because that's the definition of how we create the tangent line, a perpendicular line on this one. So I flip it and change the sign and got my -2/1. There's a invisible 1 there. And then I will get this there. But if you get that is this step. So that's this part. When I draw a line from the center to the point they gave me, which is that 1, -2, I then find the slope of that line. It looks like the radius. It looks like a radius because it is, right? And then I just do that same thing that I've been doing for multiple days. Okay, let's try number 4. I'm gonna give you a minute, and then I'm gonna silently kind of work through this. My original slope is a +1. So it looks like I drew this line. It should be here because this is -2. It's not an arbitrary one you choose, it specifically gives you. So you draw the line from the center to this point. Yeah, the rest of your process was good. So that's a tiny edit that we can make. We are right. Alright, so we're gonna work on number 4. I'm gonna do a sign of the JP. Let me see how many. Let me see.
You know, you are, so you-
It's a lot to miss. So what are you trying to, what your X showed back up? Where'd that come from?
Okay, just type it.
It does not show it. That's what I said. Or it could just poof, came back. So we're solving for B. So what is the operation of 9/4 with what we're trying to solve?
If this is
But most kids got their answers.
because that's what we did here. We did
I spent they left.
So what would we do? What would we do if I had just this?
Friday, they get donuts.
-2.
-2.
So I would subtract 2 from both sides. Yeah. That's what we're gonna do here, we're gonna subtract 9/4 from both sides. So it doesn't just turn negative, I'm actually subtracting it, so this cancels out. Even if it's a fraction, we still do that same
Yeah,
process.
I think about this.
So we are working on.
Are you asleep?
Yeah, the radius is good.
Are you asleep?
Point is good. And now honestly, it's like.
I asked you a question. I asked if you were asleep.
We'll let the lines go up. So whether or not I go up, down, or what. So now that you got the slope of this line, you need to flip it and make it negative for that. There you go. Now you're okay.
What was that?
What is that?
Just put it in the calculator. I'm not sure what to do. You have to multiply fractions and something. Yeah, very good. That's correct. Good. Now you write the equation for me with the new y. So you're just writing the equation of a line that is perpendicular to this one, that passes through that. And negative. Yes, you subtract it from both sides. Here's your slip through. Boom. Yes,
No, I copied all this on that too.
okay. Erase all that.
Where's everything?
If you copied it from River 3, yes. Yes.
This I didn't copy, I just copied.
Oh, you just copied all this, okay. Yes, so we're doing there. You have to do it for that. So something wrong. Let me hold on 1 second. Well, if it's passing through this one, oh, that's okay. It's not perpendicular. So looks like maybe if the slope was reversed, you watch around about to do line by line and see where it's good. And then let's see how it goes. All right, about to do this one. Just quietly, I want you looking. Okay. Because I don't see anything wrong with your process. No problem.
I don't know how to do it.
What you mean? What you
I
mean?
don't know what to put. Like, which one do I apply?
And so we do the intercept and then the slope.
So down, seven, up, and down.
And this is not a slope. This
No,
is
I'm not doing that. I can't fall asleep and I don't know why.
because you can't. This one, which it needs to be a decimal because you don't know what that is.
Oh, so I put this, so that into a decimal.
And then the
So
slope,
do I need to put the M into a decimal too?
because that is not going to help you. You need to rise it. You need those two components separated in the slope. All right, let me work this one for you. Number
That
four.
is good enough.
Can it be a
Why?
negative decimal?
Huh?
Can it be a negative decimal?
It
Today.
won't be a negative decimal.
The, B,
Because that wasn't good enough.
or like the slope, like B slope?
Across the base.
Yeah. Yeah, I don't know where my other example went, so I'll just, work it out somewhere else.
Yeah. It's having me like sleep.
It still doesn't make sense to the problem, so I think I have it
That's okay, look, you're on the very last step. So, you're doing really good. So just see if you can figure out like where it happened. Let me wing it here. Here we go. I need this. What is the, let me grab off some of this paper here. Number 4. Let's see if we can- Thank you, sir. Number 4, this circle equation looks like this. It's x squared plus y squared equals 25, and the point they give me is -3, -4. There you go. All right. So I need a coordinate grid. I need a coordinate grid. Making coordinate grids. Golly. Oh my God, is it trying to do another one? It's just one of those days, fine. It's one of those days, I guess. I literally have no idea what it's doing. I know. It's stuck now. That's great. Whatever. Ah, there it goes. All right. Let me move it. I'm not sure why that didn't give me my other. There we go. Okay. So we need to plot the circle. And in order to do that, we need the center, which is at 0, 0, and the radius, which is the square root of 25, which is just 5. So that would be here, and then I would count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So I'm going to have this junky little circle, 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 and the point -3, -4. -3, -4. Let me at least adjust my circle down here so we can kind of tell what's going on. That's close enough. All right, so the first thing I want to do is I want to find the slope of that line. Yep, don't know this. Welcome to my life today. All right, so the slope of this line, if we are counting, that's going to be up 4 over 3. So the slope of this line is 4 over 3. And so for my tangent line, my slope would be -3 over 4. And I need a new b. So in order to get that, I'm going to write an equation. So this will be mx plus b, where the y is -4. The m is -3 over 4. And the x, was it -3? Okay, thank you. I couldn't see it. All right. So once I'm here, it'll be -4 equals -9/4 plus b. And at this stage, I want to just add 9/4 to both sides so that I can isolate b, because that's going to make that go away. So whatever that is, -4 plus 9/4 is going to be -7/4 as a decimal, which is -1.75. Yes.
You made -9/4 positive.
It would.
Yeah, that's what I got.
Good. Yep, you're right. Y'all catching me in all kinds of slips this morning. Good job. Do you see why that happened? Do you see what they said? The -3 times -3 would give me a positive 9/4. So that would be -4 minus -4. Easy mistake. So that's -25/4, which would be -6.25 for B. Does that seem more like what people are getting out there? -6.25.
Wait, so how come it's not negative 1.75?
Because you just told me why.
No, I did the same thing you did.
Oh, because -3/4 times -3 would give me positive 9/4. We just made a
Yeah, and
little.
then I subtracted it, and then I did -4.
Minus 9/4. Double check. Ash, what'd you get?
I got it.
-6.25. Okay. Let's see what happens.
I think I changed
Change something.
7/4.
It's easy to do. There are a whole bunch of calculations here. That's why I give you a graph on every single one of these, because you can tell real quick if you messed it up when you get to the graphing stage. So this will be y equals -3/4 x minus 6.25. So let's try it. 1, 2, 3, 4, 5, 6.25. And then my new slope tells me to go down 3 and right 4. So 1, 2, 3, 1, 2, 3, 4. And now let's draw the line. Let's see if it hits the edge of that circle. Let me move it. Yep, pretty darn close. Probably just bad graphing on my part, but there it is. I think what I want you to do is I want you to, while I am working on this last one, I want you to be working on this last one. Actually, let's just start on our worksheet. Let's just try. Let's just go ahead and start on our homework. I want you to do 4 of these. 4 of these. Let me see one before you go. You got about 10 minutes, so let's try to make some good progress on at least the first one. At -6.2.
And I don't want to call. Okay.
So 1 through 4 on this. So we will do. Just do what your homework checks are. Assignment for today or tonight, whatever. It's gonna be. One through 4. Yep, there are 10 of them. I just want you to do 1 through 4. Anybody? Yes.
It's just these 4, right? Did you say 4?
Yep. All right, let me write it up here. I'm originally gonna have you do all 10, but I don't want you to do that. The rest of my examples up there. Hates me.